So what we saw in the last video was a typical request response cycle that a client used to request to a server and the data used to be sent back to him. And we saw the headers which are involved. You particularly look at an API response from a standard website, and you can this way like try to look at the response of anything. And there's a particular portal called as like a particular software called as Postman, which helps us do the calls to these APIs and see that how it is coming out. So you can use this to actually create any of this endpoints, whichever ones are there, and I can just make it point to this is a variable right now. So I can add that variable, and all these things which you were seeing here are actually the APIs which are there in my backend, and you can attach headers to it, whatever is the header which you want. You can write a body, a typical body which is there, and this is how you generally construct authentications and anything associated with the APIs. You can handle it using Postman. Now we have multiple options when it comes to let me just show you. So we can create an HTTP request. Now there is another method called as GraphQL, in which there is no schema specifically defined. Then there are certain EI kind of requests which are there, and MCP requests. Then we have something known as remote procedure calls, gRPCs, which are really used for video conferencing, live telecasting, media transmissions, and socket IO connections, web sockets, and an MQTT. So for IoT, many of these things are can be used, but the overhead is the least in MQTT, and the kind of things which you do with IoT are best aligned with a MQTT protocol. So there's always obviously a contender COAP, so it depends when to choose what. There's always a trade-off. So in this particular lecture we're going to study about MQTT. So first important thing, MQTT stands for message queuing telemetry transport. It's a communication standard often used in scalable and responsive IoT systems. It is very lightweight IoT messaging protocol that ensures reliable and secure communication over unreliable channels. So, few things to highlight. It's very lightweight IoT messaging protocol as compared to this, and you can define different services of quality services, which we'll see. So, reliability, and it provides a secure communication over unreliable channels. Very important thing is that it's an event-driven protocol, and it uses a pub/sub model to exchange data over the internet in near real time with delivery guarantees. So everyone should be knowing that what is MQTT, and how it works is that let's say that this is your data sensor, and you publish this temperature. So in between sits a broker, and anyone who is subscribed to this uh, can get that. If it was like, let's say, a scenario which was not like a broker in sitting in between, then everyone used to would have to convey their request this sensor, and then it has to respond back. So you had to make a server on the sensor itself if you want to have some sort of request response cycle. But by doing bringing this broker in between, and by allowing a good mechanism, like it can just push it publish its thing to the broker, and people can subscribe uh, to that topic and can receive that information. So So the fact that MQTT is an open source protocol and scalable up to millions of devices and is easy to implement, secure, and is not affected by tight bandwidth and power constraints, it makes it an obvious choice for IoT applications. So we'll not go much into the origin, but it was developed by IBM engineers to monitor some sensor data for oil pipelines and like having satellite links, and they set out their entire set of requirements, which later on became like an open source thing, and basis of all the IoT communication. So it has a very simple implementation. It has a delivery reliability factor built in into it. It is lightweight and bandwidth efficient and independent of types of data and continuous session awareness. So this I just explained you publish subscribe thing. So in the case of yeah, you already seen this client server model or a request response model. A client must generate a request for a server to get the required data. How in MQT PubSub model is, so the basic components of a PubSub are an MQTT client. So any device in the network that utilizes MQTT protocol is an MQTT client, and the client that generates and sends data is referred to as a publisher. And whereas any device that receives the data is known as a subscriber. Very obviously, like, nothing much to dig deep into all these aspects. It's very simple. A publisher and subscriber don't need to be in direct contact. So all this will become easy with the example which I've explained below. And the most important thing is the compute here is being provided by an MQTT broker. Like everyone is pushing that, but whom to route and what to, like, uh, again when to route with what reliability and what signals to send and acknowledge, that is handled by an MQTT broker. So as we discussed, this MQTT broker, so it's like a central node or the backend, what we call as the backend. You can call this as the backend of all the protocol, and it is the one which computes, like, what has to be routed where, and it receives messages from the publishers, sorts them according to the topic, and then routes them to the interested subscribers. So in basic, this broker like sounds simple that okay, whatever the topic is, just match, and whoever has you maintain that ID. But it has to be very fail-safe mechanism that if certain client, let's say certain IoT device disconnects and others are dependent on it for their information, then what to tell them, okay, please stop asking, because everyone will be wasting their compute. So sending the appropriate signals, and if it is not able to deliver a message to a particular client, then retrying that. So MQTT broker, although is a simple, like, sounds like a simple task, but when we actually come to the codes of how an MQTT broker is made, and then what are the retention policies, how to make it, and consider scaling to so many, like, millions of users, so can the MQTT broker still uh, perform at that scale? So that's why, like, we can use some we can create our own MQTT broker. We can write our Python code for doing that, but better would be to use a managed service. So there are a couple of managed service which are available, but yeah, before that, let's walk through one example that how a traditional thing where would be a perfect use case, and we'll be building out certain things uh, based on that. So imagine that there is a website called as Catout, and the user goes to the cart, places an order. So it has to be notified to the shipment, like packaging team. Then packaging team will pack, and it has to be told to the shipping team to, like, print the label and pick up the package, and then a notification has to be released at each step. So if you were in a central scheme, you see all these things are there which have to talk to each other, all these services. So naturally you would build something like, the app is actually connected to the packaging team, and then the delivery team sends out the notification, whatever like the updates are, it has to be front end is connected to the notification system, and all of them need to release notifications at the time, like, whenever things are happening. And so there is a lot of to and fro communication if you want to test something independently, because here every you're making it communicate to this, you're making it communicate to this is communicating to this. So a lot of moving pieces are there, and imagine scaling up the operations where multiple packaging teams are there. So how do we do this? So best is to actually involve a central trusted party, and everyone keeps sending their information there, and whatever information they have to receive, they keep receiving it from there. And this is exactly what the cloud pubsub, the Google Cloud pubsub does. So this sits like a broker in between, and whoever has to publish or subscribe to any information, they just do it via the cloud pubsub. So uh, we know all the constraints of the IoT devices, that they have very less processing power and very limited memory to store information. They need to transmit it whatever they're capturing, and bandwidth is also less, and battery has also to be very optimized. And they can disconnect, like, because these are wireless sensor networks and everything, so they can keep on connecting, disconnecting. So it has to be very uh, like, I would say, robust mechanism to exchange information amongst each other and to the nodes and to the central repository. So MQTT provides a great value in all such things, and how it does this. The main thing it does is that it's decoupling. So there are three kinds of decouplings which it provides, which is first is space decoupling. In the space decoupling, the publisher and the subscriber, basically the sensor and the client who is wanting to receive that information, they don't need to know each other's network location. So sensor just sends it to the broker. They just need to know the broker. Everyone needs to know the information about the broker, and that's it. Broker will manage everything else. It's not that a sensor has to send to five people, then they have to maintain five people's network location in their own records. They just need to send it to the broker. Now the decoupling, for the time decoupling, the publisher and subscriber don't need to be online at the same time to establish a connection. And this we'll study later also, that 7-day retention policy is there, that you've sent it to the topic, you've published the information, and now the broker's responsibility is to reliably send that information to whoever is subscribed to that topic. And if, let's say, someone who was subscribing, who was getting that information and suddenly stopped, so it's responsible to the broker that as soon as he joins back, whatever information cues had been, like, left out, all of them are sent to uh, him again and again, like, once again. And then synchronization decoupling, that the publisher and receiver can both exchange information at their own speeds without interrupting each other, or they need to get synchronized, which was a huge issue when we were, like, doing time synchronizations and etc. That lot of synchronizations were required amongst everyone to talk to each other and exchange informations. So there are multiple quality of service. QoS is a very important concept. So QoS actually refers to the quality of service, which is to make sure that the information is exchanged between clients in a reliable manner. So this is basically reliability. So QoS 0 is at most once, QoS 1 is at least once, and QoS 2 is exactly once. So any topic which you are uh, anything which you have sent to the broker as a part of your publishing to a topic, at most once you do it, at most once it can be either zero, like information is received or not received, but your thing is that from your side you have done, that's it. So QoS is at most once, doesn't survive failures. I will walk through this in the below example also. And QoS1 is at least once, that it can be multiple times that you're sharing the same information, that if it was failing, and then suddenly the device came back, and then the previous two also got delivered, third one also got delivered, but at least once it got delivered. That's what important thing is. And QoS2 is exactly once the information is received. That sequence is very important in this case. All right, so in QoS level 0, it's the most simplest and the most basic level of providing service. And the message is delivered at most once, and no acknowledgement is sent by the receiver. This means that the message is not stored, and if the delivery fails, the message is lost. And some examples are like, temperature sensor in greenhouse sending, like, to a central monitoring system. Every minute it is sending the information. So even if, let's say, that for a couple of minutes it got lost, still there is no harm, because the fluctuation is not like very dynamic, and you don't need to trace back exactly. So it's all right. So when occasional message loss is acceptable, when data is sent frequently and losing a single message has minimal impact, and when network bandwidth and latency are critical and minimal overhead is desired. QS1, on the other hand, refers to at least once. So QS1 ensures that the message is delivered at least once to the receiver. The sender stores the message until it receives an acknowledgement from the receiver. And if the acknowledgement is not received within a certain time, the message is again resent. But the problem with being is that as soon as the message comes online, then couple of messages can get delivered, and the client can think, oh, 3, 4 messages have come. But yeah, so this level of service guarantees that the message will be delivered, but duplicates may occur. So imagine a smart irrigation system that uses soil moisture sensor to determine when to water plants. The sensor sends moisture data to the central controller using QS1, and it is important that the controller receives the moisture data to make accurate watering decisions. That at least once it has to be informed. So certain real life examples we saw. So when to use QoS1 actually. So QoS1 can be used when it is critical that the message is received, but occasionally duplicates are acceptable. and when you can handle duplicate messages in your application logic, and when network reliability is moderate and you need to balance between reliability and performance. So what happens in QoS1, the computation, the number of acknowledgement signals which we send are little more, obviously more than what we expect in QoS0. But in QoS2 we have to ensure that it is delivered exactly once. Now this becomes very important when sequences or something like, sequencing is important. So QoS2 is the highest level of service in MQTT and ensures that the message is delivered exactly once. This involves a four-step handshake process between the sender and receiver to guarantee that the message is neither lost nor duplicated. And this provides the highest reliability, but at the cost of increased complexity, because even if one signal is missing from here and there, then it repeats the entire process once again after the time to live expires. The So consider financial transaction system where IoT devices are used for point of sale transactions. Each transaction message must be delivered exactly once to prevent any possibility of duplicate charges or lost transactions. So when message duplication is unacceptable, when the highest level of reliability is required, and dealing with critical data that must be accurately processed, such as financial transactions, medical data, or control commands in industrial automation. So these are the examples where we require QoS level 2. Now, what we'll see is some basic pub sub uh, flows. So what happens is that, imagine that there is a publisher, as we were seeing that cat flow example, the user, and whatever information they have, they just send that message to a topic. Now this entire thing becomes part of the broker. So the topic, whatever the topic is that we've predefined, and this entire box which you're seeing, this entire thing becomes the broker. So it communicates on a topic to a broker, and then broker has some in storage, message storage, memory, and time to live, etc. And then whatever, it's the broker's responsibility that whatever subscriber has this subscription to, and whatever topic and subscription links are made, so all those subscribers are sent out that message, whoever has the subscription for this. And whenever the message is sent, uh, either via push or pull mechanism, so subscriber needs to acknowledge back that okay, I have received it. And the publisher also has to have the payload attributes so that everything is in sync. Now there are like many type of communication patterns which are possible. So first is fan out, which is one publisher sends messages to multiple subscribers. Then fan in, which is multiple publishers sending message to just one subscriber. And then there is many to many, in which multiple publishers are there and multiple subscribers are there. So looking at this case, if you have to identify like in which scenario what is happening. So this is multiple publishers sending the topic A, topic B, and this subscriber has subscribed to both XA and XB. So this falls under which category? Fan in. And this one, a publisher is publishing to a topic, and a subscription has got subscription for this topic. So multiple subscribers are there. So this falls into the category of fan out. One too many. Now communication can be fan out, as I explained, and yeah, you just be should be aware that for what purposes we'll be using what. Now the cloud pub sub service integration. So we'll make this broker actually on GCP, and we'll see that how this entire thing is working. It's a very interesting exercise to see. You'll be saving like couple of $100 per month if you utilize this service of pub sub from Google Cloud, as opposed to like using some other service, which I'll show it to you. So, and like how it works is basically mm, you have couple of data sources with you, whether it's apps, mobiles, webs, databases, IT devices, front end, change data captures, IoT cores, other event producers. So whatever events you're having, all those events via front end server, they come into the topic. They publish to a topic, and then whoever has subscribed to that topic, whatever subscriptions are there, based on that, the information is given. If it's like a subscriber can pull the information, can okay something some new thing came, then it will respond back, oh, this new thing came. Here it will automatically push, the cloud will automatically push to something like a webhook, that okay, here is the information, just take it, and in that webhook this WebSocket will be open, and that webhook, it will just capture from there and acknowledge it. So for all this ordering, uh, avoidance of deduplication and enrichment of the data, so for all this broker is used, and the target is also like, whatever target we have, that can be like, oh, so you see that here all the sources of data from which you can capture into this pub sub model, and then in the data flow you can send it again to logging for IoT core device, or you can just inform any other IoT device like an actuator, that okay, this is what I have sent, this is what you need to do now, and you can alter the end state requests, user states, can notify, etc. So cloud functions, cloud run, all these things are event driven. Like, anytime an event happens, they're just using PubSub model, they just fire off like a cron job. And it is used all the time in creating backend architectures, not just related to IoT, but even to like other things. So cloud functions, app engines, and cloud run, that these are the uh, important ones. So how do we practically implement this? So we were looking at this example, um yeah, this example. So let's pick up this ordering example, like, if once the order is placed from the app, then what will happen? So so consider this order service, and once it publishes that okay, to an order topic, information has been sent like order received, then the packaging and the notification channel, like, both will receive this information, and they want to do take some action based on that. So the packaging subscriber, the warehouse, will receive this, and those notifications, the people who, like, the app or service which has to notify, that will receive, then order has received, like a WhatsApp message queuing, like as soon as you place the order, this information goes to the notification subscriber, and it releases a WhatsApp message. So we'll create the cloud pub sub topics and subscriptions on the GCP account, and set up a service account in Cloud IAM, and give it the appropriate permissions. And then we'll start the publisher and subscriber apps and send sample messages. So firstly, as I said, we'll go to the Google Cloud Console, and then we'll keep on following this. So we'll create a topic called as order topic, and whatever the project we are creating, I might not create a new project, this is just like, for you, if you're following along on the GCP. So first we'll add this order topic, so let's go to the GCP now. So this is Google Cloud, and yeah, it's a amazing uh, experience to actually use it, the different API sections and how the keys are managed, everything. It's quite nice actually. All the services which you look for are available. So before I like you know we dive deep into this particular example of PubSub, I would just like to show you the entire landscape of services which are available to a user. So um, all products. So all these things related to the APIs and services of different, like, APIs are there, like Google Face API, Document Intelligence API, that you just send your data to that. They will charge you based on a pricing, and they will give back information to you. And admin for Gemini, all these things are there inside the management related things for now. Then in the compute, so you can run scalable and virtual machines. So obviously the basic virtual machines, GPUs, TPUs, disks, everything is there in the compute engine. And managing the Kubernetes or the containers, Kubernetes engine is used. Then there are like other services, VMware as a service, managed cluster for AI and high performance computing, jobs as a service, like you keep on queuing your job in a thing, submit, run, and manage your batch workloads. So for that, batch thing is there, license management, workload manager. Now for storage, we have like enterprise ready object storage. Whatever you want to store, just store it in cloud storage. Fully managed NFS, uh, backup administration, storage transfer, etc. All that is there in storage. Inside analytics, now we see collect, store, and process and analyze large amounts of data. So BigQuery is a very big thing in data warehousing. I'm not sure whether it is being taught, but BigQuery is like fully managed, highly scalable data warehouse, and it has a lot of machine learning things embedded inside it, and it is very easy to analyze and very quick to analyze all these things. It's like a managed database, SQL based. PubSub, as I just explained you about real-time messaging. uh, then this is about streaming analytics, develop real-time batch and stream data. So all those communications, like if I was doing a Zoom call or something, I would have probably used data flow. And Composer, for like pipelines and building the DevOps cycle, etc. Many things are there. It would not be possible to go through all these things obviously, but related to networking, we have then distributed cloud. Then we have certain serverless functions that do not actually run on a server. They're like content is distributed, and whenever you request to that, the function just loads, executes that function, and whatever it has to do, it just does it in that and updates like a db or a kv store, and it closes, like gone from the memory, gone from that processing cycle. So it generally has a small cold start period, like whatever function you want to load to the memory, it has like 2 3 seconds, not 2 3 seconds of cold start. It has reduced to very less, but Cloudflare also is like a very strong contender in this, in the serverless applications. Then in the databases, we have the Cloud SQL, Firestore, Spanner, Bigtable, Neo4j, GraphDB, which is Redis Cloud. Then for observability, we have logging, operations are there. For security, app development, Firebase is there, which is very common. Uh, and for doing the CI/CD pipelines, this integrate and deliver continuously, we have cloud build. So anytime you push some code to your production, it will ensure that all the test cases are passing and the code is like running properly and nothing is breaking before it pushes. Artifact registry, so storage manage and build uh, artifacts and dependencies. So this is like um, like a Docker repository. Like we store our code in GitHub, so there is this, we store our operating systems, the Docker containers in the Docker repository. So this is like a Docker repository, and deploying that is easy. And obviously our favorite, AI workloads. So we have Vertex AI. Every ML tool you need is there in this. Translation API, translations are there, document analysis, classification, searches are there, and certain insights you want about your data, talent solutions, on-device ML model testing. So all these are different things which people are at Google are working on. Yeah. So and Google, obviously the Google Maps is a very important service and it's released as an API. But for us, I would just wanted to walk you through that what all things are there in the cloud service, because it's like a fully managed thing. If you write your own code of MQTT, you will run into thousands of issues. But choosing a managed service of PubSub, it will ensure the entire thing is happening smoothly for you. And we'll go over through these advantages shortly. So publish and receive messages in PubSub. Learn how to create a topic and subscription in PubSub and send some tutorials. So enable PubSub in Google Cloud Project. So in the server project, things are already like enabled, and also I have this thing installed on my computer itself. This is this server, and yeah, I'll just yes. So this Docker thing is also installed. Right? You don't need access to Docker for this, following along on this, but definitely you need access to G Cloud. So available commands for gcloud are there, and artifacts, everything what we just saw, apps, compute container, everything, whatever service you want to use, we can, again, like, it's showing us so many services which are available from Google Cloud. I possibly do not know till how long this list will go. All right. So we have gcloud auth. So we have to, first of all, before we begin anything, we have to do gcloud auth login. So once we do gcloud auth login, it will ask us to authenticate this entire thing. So, and then we allow it all the permissions, and then you're now logged in as this. So we can do gcloud auth list to just verify that our current is the one which we are using. So we can select the project ID, like, whatever project we are creating this entire thing on. So we can select that project ID, and definitely I would like to use this project ID. But yeah, we'll just execute those commands, don't worry. So I'll click on start. So create a new project to ensure that you have permissions you need. So I'll click on next. Now it says go to the pub sub page, and in the topics page, click create topic. In the topic, enter my topic in the field and leave the default values. You can see a subscription message. So instead of telling what they are doing, what they are telling us, we'll create a topic called as what we are following in our sheet, order underscore topic. All right. So it can export message to the BigQuery, to the cloud storage, whatever the incoming thing is there, we can just export it that. And yep, that's it. So I'll click on create, and next we need to create a subscription. So the subscriptions, we'll create two subscriptions called as package sub and the notification sub, and delivery type we'll choose as pull by default, so that we're just pulling things and we're not creating a WebSocket, and the expiry and everything we can keep that. So uh, We'll just create packet sub and notification underscore sub. So order topic permissions, these things, let's just, I mean, all these things can be granularly controlled, that who can call it, who cannot call it. But we'll, for our side, we'll just keep it a little more simplified. We'll just go to the subscriptions now, and so it automatically created this order topic sub. No worries, we forgot to like tick that option off, but we can create a subscription called as um, package sub, and we can select this topic, and delivery type we can choose as pull. And message retention duration, the more the you retain the message, the more costly it will be for you. Obviously not too costly at the same time, like, but little more expensive than what you would have originally done. And then an acknowledged deadline is like 60 seconds, and some subscription filter like this should not have this should not have that, kind of things. And if return retry policy will be triggered, or acknowledgement deadline exceeded. So I'll create this subscription. So right now there are two subscriptions, and I'll create just one more subscription, which is notification underscore sub, and the same topic which we have, and again it will be pull. Things will remain default the same. Only thing is, yeah, everything looks good to me. So let's click on create. So now we have this service ready with us, that a broker is there. Broker was already existing as soon, like, broker was already there. As soon as I enabled this API, before, like, come to PubSub and you do all this, you'll see an enable option. Once you enable it, then a broker is already assigned that, but that broker does not have any topic or any subscription. So now we have created the topic, and that subscription is also there. All right. So if you want to see it from the front end itself, so it's giving an option, I think, order topic, trigger cloud function. Let me just zoom out a little bit. Yeah. So subscriptions, all these three things have subscribed to this, and test if your subscription can receive a manually published message. So we can enter anything, and we can click on publish. So message body, hello IoT class. So we just publish this message, and now whatever. So if you want to, like, pull this from any of these things, then we can just, like, select from where to pull the things from. So as soon as I launch this thing, so this one I'm trying to do this here because it's the GUI. Obviously you cannot do GUI, you have to integrate something in your Python code, because your Raspberry Pi, or either as a Node MCU or anything, it has to publish this topic, whatever you think, from that device, from that sensor data. So doing it on the GUI is just telling us that okay, it is working out. So all right. Hello IoT class. So you saw that this thing has come, and enable acknowledge to acknowledge before it expired. So the deadline got exceeded. So I'll enable acknowledgement message. So as long as that is not done, if I'll again pull, that message will come, but this time I'll just acknowledge it. So now this message has been acknowledged, and broker knows that I don't need to, like, send this message again. Like, nothing's coming until unless I publish a new message. All right, so it's just waiting. It'll just wait for anything to happen. And I hope this, like, gives you a good sense that what we're trying to achieve with the sensor data. Once you are there on the Python SDK, that'll make much more sense to you. So our accounts are running, but now what we need to do is we need to authenticate this entire thing from our computer. Now how will a computer know that any random virus a person is throwing? So we need to be authenticated, that who can actually send data onto this device. So for that we need some JSON keys, which will it's like a small API key which will be there, which will help us set up the entire thing. So what we'll do is we'll go ahead by creating a service account, and we'll just download the keys which has access to publishing and subscribing here. So you can go to IAM services, and you can go to service accounts. So service account represents a Google Cloud service identity such as a code running on compute engine, VMs, app engines, etc. And one I've already is there. Um, Click on create service account, and you can just give it the account name, like, pops up. And this is like a temporary service account which will be created, and the permissions which we need to attach to this account are like pub sub publisher and pub sub subscriber. So pub sub, first we'll do pub sub publisher, and we'll add another role, pub sub subscriber, and what all topics and etc, those things we can add that also. So in one shot you can just give it pub sub admin thing, like full access to topic subscriptions, snapshots, etc. All those things will be available to this. But yeah, that's a more privileged thing, and it's not a good IoT practice to just do that. So view topic subscriptions and snapshots. So we can just, instead of writing permissions, we're just giving it view only permissions, and you can click on continue. So grant access to users or groups that need to perform actions on this service account. So this is basically some users, like, if I'm added, like, let's say you are part of I'm the admin and I'm the DevOps team, and you people I have added onto this. So whether you people are allowed to use this, what all permissions you have access to. So I can just, like, for me, like, let's say I've added my bits email and all those things. So service account admin roles. I think I could have left it default as well. I think I have a feeling that I can leave it as default also, because this is the same account which I'm using to create this. Like, this was the account which I was using, but I'm getting a little confused. I think I can simply click on done. Then I can manage the keys, and I can add a key here and click on create new key, and I'll download this JSON key. All right, let me just resolve this issue. So I'll just go through this and uh, try to see that how to fix this. Basically, you just have to do some chat GPT and come up with a thing that how you can fix all this. So I'll just follow along and maybe I'll show it to you towards the end. All right, so I've just asked this to generate some commands, and I'll be adding them here. So yeah, gcloud config set project. So I've set my project to the basic thing, and now replace list all keys for a service account. So this service account which I created in this step here, this service account, I'll just ask ChatGPT to directly. So basically, in order to generate that, the fixes that to this my primary account which is there, instead of just having the owner ad role, I also give it the organizational administrator role as well. So once I have this change with me available, so I can go and I can search for that particular thing which was stopping me to create the accounts. So now I can. So it will take some few minutes to yeah, let me just spend some few minutes to get that changes on that rule. So this was actually an organization account, and that's why some things were happening. But nonetheless, we have our JSON key right now in our downloads folder, which we can use. So I'll just call it key.json file, and so yeah, now we'll use this to actually authenticate whatever we're publishing. All right, so there's a much easier way which I figured out that obviously in your personal email IDs you can simply go ahead with downloading that keys.json file. But what you can do is for accessing all your cloud services, you can have a default access token, and you can do that gcloud auth application default login. And once you execute this step now, so let me show it to you. Oh, it's sorry. This I've already logged in actually. Let me just redo it. We already have this access token. So with this access token, we can as we saw that we can uh, we had created one order topic list and we had created three subscription lists. So all of it is appearing here, the notification, the package, and the push configurations if there are any. But for any of these things, push configuration is not there, and the status of it. So now in this pub.py file, we can copy the entire code which is available here, and we can just write the order received message, and we can just launch this code. So to do that, similarly, we can create the sub.py code as well, and an acknowledgement that it will, what this code is basically doing is that it is creating this pub with project ID and topic, and it is creating a client and an object, and on that client the topic path whatever we have done, storing this data, and the client returns like this API future is equal to whatever data we want to load in that. So client dot publish, and then we receive that ID, and whatever that message ID is, we'll be printing it here. Then this is how we are launching the entire thing, like just taking some commands from that command line itself and just passing it to this function. Similarly, for the sub also, we're doing the same thing, along with the timeout value and the callback options and this error parsing code. So that also we'll take care of. So by the way, in the starting only, I have pre-installed this Google Cloud because the Python library will not be available to you. As of now, we just downloaded Google Cloud, but not the Python library. So that we'll have to install separately. And let's just, since we've opened a new project, new tab, so this variable has to be exported again. Okay. All right. This project is not set yet. So obviously, if your IoT device supports like this sort of a command, like it has the G Cloud capability. It's not very easy for an IoT device, obviously, but you can directly do it using the terminal command line. You can launch it as a process. But for our Python thing, we would need this sort of access. So I'll just probably like do a small hack here. I'll get the project ID, which I already knew from the starting, and instead of this, I'll directly hard code this project ID. So now if I run this command, so publish order message received to this particular topic, and now let's say I want to review this from the packet sub. So this message has already been enqueued. The broker would have immediately tried to do that. Like as soon as this was, if we launch it in two separate terminals, let's try and do that. So from this one, I'll just, yeah, this one is already listening to the message. So if I publish anything here right now, let me just, okay, this already got executed. Let me just change the message to order received message to order to received order number 543. So now if we execute, so as soon as we send it, the broker will actually send that message there. And remember, all these things that we have sent, we've just received it on the packet subscription. But let's go back to our subscriptions, and we saw that if we pull uh, messages. So until unless we acknowledge all those messages, it will not come. So now if I pull this message for the order topic sub, now it should, all those messages which we have released, all of them would come in that sequence, top to bottom. So that was like a message queue which had, and until unless we acknowledge all these messages, so deadline exceeded. Now if we again pull it, so this message will come again. So this is the beauty of MQTT protocol, that how it is ensuring. And this which you're seeing is a managed service. Now there is one another service which I have taught previously, but since like this is very expensive, if you go to the pricing of this, so this is basically PubNub. So this is like the market leading platform for real time interactive apps, and they provide, like they've created wrapper around, they've created their own optimization, just like how Google Cloud has created an optimization of MQTT. They have themselves created like a wrapper on top of that MQTT, or even made some algorithmic optimizations on their MQTT protocol and their content delivery network, so that things get delivered faster. And who knows, possibly they might be using the same thing which we just now tried out under the hood. So there. Like, point is that for anything which is related to streaming or something, like, they'll be on top of it, like real-time communication with low latency, messaging service, in-app messaging, mobile push notifications, event hub. So they have tried to do what they've tried to already see MQTT instead of building from ground up. That okay, they've already created a managed service. You just have to hook it up in the correct place, and it will do that push notifications. And they have written all that code for you. So it's not, with this sort of a understanding, it's not difficult to build a thing. And if you just look at their pricing, then it starts at $90 per month. And trust me, people do use this when like when using their startups or something, because it makes it easy. But now you have, like, the complete clarity on um, how to do this. So also one thing that they provide their SDKs on, like, all, like, even for uh, objective C, like, which is used I think in Apple docs or something, I'm not sure, in Apple programming. um, the one which is most relevant to us is obviously being the Python. So you just install, just like how we did that, you just pip install and you import their API key, and whatever topics you have made here and, like, are wanting to configure on different clients, you can just go ahead and use this to use this. So coming back to just now our slides, there have been some updates to this original one, but the ones which you were discussing. So all these things we have already looked at. Now let's focus ourselves a little bit more on the theory part. So all these things we've checked out already, that the publishers can configure message batching. Like, instead of publishing just one single message, which is ensuring low latency, if the IoT, the transmission is always and obviously an issue always. So what we do is, like, we batch these things together, and request size in batches, number of messages, and the time before which it will be sent. So all these things we configure if you want to explicitly do that batch settings, and we pass that while we are creating the client. And as we saw that there is an acknowledged deadline, that if it is not met, it will, like, restart, like it will try to resend, it will not remove it from the queue. And one thing very important to note is that this topic, multiple topics cannot be sending to the same subscription. So this type of a thing is not possible, configuration is not possible. So key principles for subscription management: a topic can have multiple subscriptions, but a given subscription belongs to a single topic. Messages are stored until acknowledged by the subscribers. This we have looked at. Acknowledgement deadline determines message redelivery timing, and proper subscription naming prevents conflicts. Now, one interesting thing, what we were seeing is that most of it was like pull. As a subscriber, we used to pull the data, and then the data used to come to us. But what if we truly want to make it like a event driven architecture, where if something happens, then based on that we're taking an action. So this is like a push operation, and here we send the message and then modify acknowledge deadline, and then this immediately it will send this modify acknowledge deadline to tell in what deadline to expect the acknowledge signal, and it will send that acknowledge signal as well. So we have to choose pull subscriptions if the large volume of messages are there, and there is a critical efficiency and throughput requirement, and there is no public HTTPS endpoint which we can configure for that. So in all these scenarios, pull sort of a thing works best. But if we have, like, multiple topics for same webhook, or app engine standard and cloud functions we are using, which based on some event they have to trigger something, so that triggering sort of thing can only be done by push. And where the GCP G cloud things cannot be put, like, you cannot pull things, so all those things, push option is better. So this hands-on implementation we have already taken a look at. Now just look at some advanced cloud integrations which are there. So how typically, like, whatever your sensor data is, IoT sensor data is, you would typically take the data from there, and either on Android things, CPU, GPU, whatever it is, either on your edge device, you'll do some analytics, and then you'll send this data to the cloud IoT core. Cloud IoT core is directly, like, ingesting the data and sending it to the pub sub. And if as soon as the data is received, if some functions need to be hit along with the data, cloud functions will take care of it. and the cloud data flow will take care of how to put that data which is incoming into a BigQuery table, or like a BigQuery or a big table, or and maybe also like use it to store it in the machine learning to retrain this model. And further, the data usage, whether it is required in data lab or in data studio, capturing insights, you can capture from here. So modern IoT system often integrates edge computing with cloud analytics, and this is what we've just now shown, that how it is made possible using MQTT. So there is one more thing which one more diagram. So edge gateway, where we ensure the storage of certificates and edge software device connectors, and then there is a cloud balancing load setting in between. So what happens is that the device authentication configuration, like all this platform, IoT platform provides the device management, the connectivity features, the messaging queues, analytics, and applications, whatever you have to build on top of it, like including cloud functions and app engine. And yes, so in this diagram, this is like basically trying to explain the same thing, that MQTT bridge and broker is there, and certain connectors are there which are actually linked to the messaging queues, and the backend application is having data analytics, IoT, and all these things. And all these project level resources are being managed by all these services here. Whatever IoT device, like device management is required on the IoT device, the device credential store, device registry, all these different rules are available, and a device management API is there which will help us manage the device from the server. So this is another small example, like how you can use the PubNub which I just showed you. So if it's like we have an application in which we want to log the light and the moisture and the pH level. So for every MQTT, every IoT device which we have, there'll be a topic which we'll be publishing to, and the RX and TX of this would be connected to the sensors RX TX, and these are all the actuators which will subscribe, and these are all the sensors. So based on the information from these sensors, since each node MCU just has uh, two TX and two RX pins. So therefore, not more than that can be added either as an sensor or as an actuator. So therefore, three are required. And via local network, they are connected to edge device RPi, and it is streaming, like all these are like via internet, putting things onto the MQTT protocol, which is being received by PubNub. And the analytics of the actuators, the speed, and all those things, these are having a direct communication with each other. And then on the client PC, remember the how internet works, whatever we want as an app interface, we give it to the login request, somewhere it is sitting in some server. Now we have a really good idea about it, and how it generates the authentication request, how the Facebook returns the tokens, and how the response is made. So yeah, this is a very practical MQTT implementation using ESP32 devices. And these are the communication topics which we saw here, and the connectivity. So yeah, feel free to actually try and implement different things in your project with MQTT, see what you can do. And it's a very interesting protocol, and it's a very widely and genuinely used, and now we have cracked the basics of how to implement even on the GCP, which is a very big thing. So thank you so much.